This is problem 2C from the Conservation of Energy Expert TA homework. So it says a brick with a mass of 0.43 kilograms, which is right here, is set against a spring with a spring constant of 597 newton meters, so this spring right here, and has been compressed by a distance of 0.1 meters. Some distance in front of it, which we find out to be 1 meter, so that's talking about the distance between the two springs, is another spring with a spring constant of 205 newton meters. So this spring has a spring constant of 205 newton meters. And in between, it's not frictionless, like it says up here. For part C, we learned that there is friction, and the coefficient of friction is 0.5. So that is everything we need to get started on the problem. So we are trying to solve for how far the spring is compressed after the block is pushed into it by the other spring, and then obviously after it travels across the 1 meter that has friction. The only energy that's relevant at E1 is the potential energy from the spring. In between the E1, and we'll call this E2, the force of friction is moving this way, so against the direction of the block, so that's why I'm subtracting force of friction from the potential energy of the first spring, and then that will equal the potential energy when it reaches the second spring. So now I have just filled in the equations for the spring constant, the force of friction, and then another spring constant. So it's important to remember that the first spring has a different spring constant than the second one, so that's why it's K1 and K2. And also the distances are different, or at least they can be. They don't represent the same thing. Now I just filled in the values for everything in the equation besides what we are solving for, which is x2, the distance that the second spring is compressed. It's important to remember in this step that the force of gravity is negative because in the picture it tells us that in the y direction up is positive, but we know that gravity points down. When you just do algebra, this is what you end up with. So to get the value, you just take the square root, and then that leaves you with 0.093 meters as the distance that the second spring is compressed. It's important to write out all of the units, that way you are positive that you got the right units for your answer. Obviously the distance that the second spring is compressed in would be measured in meters, so that doesn't raise any red flags.